Okay, I guess we're ready to start again. For our next panel, and I can't really introduce Alina because she was introduced as a speaker in the last panel, but I did want to make a quick comment. I've noticed in the DDI world that there's been a little bit of a renaissance in France. Alina talked about the French language training. DDI has never done training in any language that wasn't English. And that was a first, and there are a bunch of organizations now in France that have started using DDI, and there seems to be a bit of like I say, it's a renaissance. And I just wanted to say about Alina that Sciences Po has been at the forefront of that, and Alina has done a lot of work organizing EDI and being really, really supportive of people, volunteering a lot of her time to DDI. And I'm not sure that came through in your official bio, Alina, but she's done a lot of work to make that happen. So I wanted to make sure that people were aware of that. And so I'm going to turn it over to you to run this cast of these distinguished speakers, I guess.
Yeah, thank you so much, and welcome to session 5. We'll have 4 talks, 2 long papers and 2 short papers. So please remember, I will be really strict on time. 15 minutes for the long papers and 10 for the short papers, and we'll have time for questions. So the first speaker will be Archana Bidargaddi. She's a product owner and IT team lead for Sikt research data platform. Sikt is the Norwegian agency for shared services in education and research. She has over 15 years of experience in building solutions for making research data fair, and her expertise is solution architecture for research data infrastructure. So the floor is yours. Thank you.
Thank you for this invitation, and we from Sikt are very excited to be part of Cosmos, the first conference on smart metadata. And when we read what the program was, it matched so much to the work we are doing at Sikt, and it is a conference that we wanted to be part of. And for people who do not know Sikt much, Sikt. Previously, we were part of NSD, the Norwegian Social Archive, and we also had the software called Nestar. Probably many of you have heard over yesterday and today. And that's briefly about us. And I wanted to start with our dissemination service called Surveybanken. And how does this match to the official statistics? Because the conference is about official statistics, and we don't do official statistics. However, we archive data from the Norwegian Statistical Bureau, the survey data, and we make them available for research purposes. On the other hand, we also build solutions to make register data, which SSB holds, available for research purposes. So our main input here would be making data available for research purposes, and we come in building solutions for that. And Surveybanken is in English, the survey bank. It's the dissemination platform for solving the FAIR problem. Findable, most often we are unable to find data. And once we find the data, the access conditions are complex and it's not easy to access the data. Interoperable, wherein the machine actionability is low and insufficient metadata to make sense of the data that is provided and to reuse it, both by machines and by humans. And what we have done is we have a history of 50 years of working to make data available for research. So we have gone from the punch cards to what we have today. So it's not just the last 5-10 years, but the 50 years of experience we have brought in. And the experiences we have seen, the complexity was, though we added metadata, often though we added deep metadata, they were not available, they were not searchable, they were not machine actionable. And through multiple projects over the last 10 years, we have modernized our infrastructure to actually make metadata we add at the variable level interactable, machine actionable. And we have built solutions that are driven by metadata, search, visualization, analysis, and data access. All of this, the machines can interpret metadata, understand them, know what decisions they have to take, and act on them and drive systems. And this is one of the screenshots from the survey bank. Here, if you see the variable, how concerned are you about climate change? It's just not the visualization of the variable itself, the question itself, but also the user is able to see on the fly how against the gender, against economic, and also education. How did this happen? This was possible because in the metadata, we define the variable as what kind of the variable is. We define what are the break variables. We define the weighting. And all this defined in the metadata, the systems are able to actually understand and act upon that. So this is not hard-coded at the system level, but at metadata level, and can be changed as the curators deem relevant. Similarly, we have map, and this map is also, again, entered in the metadata, and what map we have to use, and which variables have to be shown on the map. And this is, again, the system interprets the metadata and able to show. And we have developed tabulation for variables with maximum 3 variables. We do not allow more than 3 variables because then the display becomes complex, and all this data is accessible. People can apply and get access. So we do not want to complicate discoverability. And again, what kind of visualization one has to show? Is it a bar chart, box plot, or scatter plot is decided on the fly by the machine based on the type of variables that have been selected. And how did this happen? The Norwegian Research Data Archive has diverse data. This is not just one study or studies that are internal to Sikt, but studies from, like as I mentioned, SSB or other institutions and research projects that have been delivered to us. And we curate the data to make it enabled for long-term archival, which we say 50 years, and then also accessible and disseminate them. We had previously a very distributed, disjoint, heterogeneous infrastructure. And the legacy looked, the center of the heart of our infrastructure was Nestor, obviously. And then we had around it Redmine for ticketing, email-based communications, and SPSS for data processing, and multiple other things. But none of the systems talk to each other. These were disjoint and had to be like logically maintained, manually maintained. Like you write a huge Word document saying, do this, then go to this Excel file, do this here kind of thing. So this was a very manual-driven system. And we wanted to go away from this and see how we can drive all of these systems and services by metadata. And the background for this legacy system we had more than 20 instances of Nestor within NSD, and we had 2,500 studies, and we had 90% documented at variable level, and a lot of it was manual. What we went to do was major modernization projects, and we went from on-premise to the cloud. And while doing this, we also built a lot of value-added services. We changed the quality of our metadata and migrated from codebook to lifecycle. So we have talked about FAIR a lot, and findable and accessible were something we thought was easier, and the most complex was interoperable and reusable, and that's what the challenges we wanted to solve. And we were focusing on transforming static metadata to smart metadata. And the goal was wherein the curators have control over the metadata, the single truth for metadata, the metadata is versioned, highly controlled, and can drive systems. And the process was we cleaned and harmonizing of metadata, DDI lifecycle, metadata profile, defining it that kind of helps us control the quality, transforming metadata to be machine actionable, migration process, and then enabling metadata-driven services. And not the least, and not to forget, the connecting data and metadata, because without this connection, the whole system falls apart. Our analysis, download, visualization falls apart if the metadata does not know exactly which data file it has to refer to. And then we had a lot of dirty metadata. I won't go through the details here, but a lot of dirty data over the last 30 years built by human challenges and the DDI challenges and Nestor challenges, all that. And we had to clean this up. And we did a lot of hard decisions. We dropped the whole keyword system. We just dropped all of keywords because it was very subjective. We had no way of cleaning up keywords. So we dropped the keywords. But what also we kind of made decisions to kind of flatten out the organizations. We had a lot of hierarchical organizations which we kind of flattened up to the top level. And we made decisions to kind of access conditions. A lot of customer access conditions. From 2,700, we went to 6 access conditions. This is a huge jump in predictability and quality of how we define access. So this was major, both domain and technical decisions taken. And also DDI lifecycle metadata profile had to take into consideration as to the SESTA metadata profile available, the limitations in Collectica, limitations in our own process, and what we wanted to achieve. The major work we did was we did a subset of SESTA metadata model, and also we did upgrades to Collectica, wherein we got control vocabulary supported, and DDI elements, creator, contributors, and publisher were structured, how they were structured. This kind of boosted control over metadata and the quality of the metadata we have. And so we also have concept schemes, organization schemes, code lists, and archive groups, and other materials. So the whole work, this took us around a year and a half, the whole work of cleaning and migrating, learning. So this was a very agile and iterative process and intensive. We involved both internal IT people, domain experts, and Collectica doing this work over a year and a half. And this kind of helped us build services that finally could drive dissemination, search, and analysis, download, everything. And major of enabling metadata services we have talked persistent IDs, we have talked about control vocabularies and unique IDs, but versioning is crucial, and control over versioning is very crucial if we have to drive systems. And that, I think, we managed to achieve. And we use flat files, we use SPSS files as long-term archival, but for dissemination purposes, we are using Parquet format. And we build our own services, which kind of reads the Parquet format based on the metadata and can generate statistics. So I just have 2 minutes to go. This is our architecture, and I think many of you have seen this architecture. I just have a word on this, is that this was not a blueprint we started with. This is an architecture we ended with. So that is very important. If anybody is taking on modernization of their infrastructure, be open, be agile, be explorative, and then land into an infrastructure that is applicable to your use cases. So the infrastructure architecture you see here is a result of the work we have done over 5 to 6 years and not a starting point. And this has given us a launch pad to increase different kind of projects. We are launching on to modernizing qualitative data now. It may not fit into exactly this, but the experiences we have had here will help us into modernizing qualitative data, which is a new domain for us. Though we have qualitative data, we have not modernized the infrastructure. So I have 1 more minute. Yeah. So I just briefly want to mention the protocols we have adopted, DDI lifecycle. And we didn't want to go on custom metadata standards or make our own mix and match. And we have stuck to DDI lifecycle. And GraphQL API has been a boon for us as the central communication channel between internal and external services. So this is the only channel all systems talk to each other. And OAuth for login for accessing the data, Terraforms for defining the cloud infrastructure, Pocket for the flat files, and JSON for the metadata. And the recommendations we have is, I briefly mentioned, have an agile approach, cross-functional team with expertise that is cross-cutting, technical, domain, data, and policies, and also have the mandate to make hard decisions. And API first, enabling metadata-driven systems, building data solutions for download and analysis, and connect data and metadata. So this was wraparound for me. And this paper was written by Morten Jacobsen, my colleague, and myself. Thank you so much.
Thank you. Thank you. Any questions from the audience? Yeah, there's one question here.
I'll take from here.
Yeah, I'll take it from here. Oh, yeah, that's do it as you want, in fact.
Thank you so much. It's a straightforward question, probably. I'm just curious about what you said regarding dropping the keyword system, because you didn't have a clear criteria. That's it, or
we used ELST to do the keywording, and it was very subjective selection. So we didn't know how to clean them up because they were so subjective. So what we have done is we have indexed the whole metadata and making it available for search. So we don't want to go the keyword way at all.
you don't need it? Okay, thank you.
Thank you. We have time for one more question, even two if we are quick. I have a question for you. There was one? No. At the beginning, you showed the fair slide, but I think you should maybe you already. No, the thing is there, still there. You showed the fair slide with the initial situation. Do you think you would be able to translate into fair what you did in the end, the final result?
Yes.
Okay, that would be really nice.
Here, I would actually confess one thing. The findability, we thought we had good control over, but actually our metadata was not Googleable. And this was an architectural decision we failed at, but it was not a major, because we chose a single application for dissemination, and that is not indexable in Google. So we're going to change that into server-side, and we have fixed it on the roundabout. But apart from that, our metadata is in standard, it is interoperable, and also it drives machines. And we are not at the moment aiming at connecting with other organizations because we have to get order in our own house. But we are, and since we have used vocabularies, that is DDI vocabulary, CMM model, we are sticking to the standards as much as possible so that if we have to collaborate with other organizations and institutions, it would be easier.
Thank you so much. We would have time for a really quick question. Yes?
Is your GraphQL API, is it open source?
Not open source, but it's open to access our metadata, but it's not open source.
Thank you so much. Okay, go ahead. 30 seconds, so be quick.
We started in 2018. Yeah, how long did it take? Okay, it took from 2018 we started the projects, and we have had multiple projects actually feeding into the modernization. One was the Nordi, financed by Norwegian Research Council. We had ESS Shock, EU funded, and we had internal modernization projects. So there were 3 to 4 projects that kind of led into this modernization, and it cost more than 75 million Norwegian kroner. That is, yeah.
A lot. Thank you so much. Let's go to the second presentation from Juan Muñoz López, who has a PhD in computer sciences. He's the Director of Informatics, Planning and Normativity at INEGI, which is the National Institute of Statistics and Geography of Mexico, where he works in the strategy, governance, coordination, and modernization aspects of information and communication technologies. He's a professor and a researcher at the Autonomous University of Aguas Calientes in the Information Systems Department. So the floor is yours, please.
Thank you. Well, I hope not to take too much time on this presentation. Trust me, I will do my best, because the way I have prepared it is, I think you will be eager to read the paper, because right now I'm going to touch some points, address some points that are important about the way we work and how we can achieve interoperability between domains, statistical domains. And, well, I will start trying to put the problem that we have when we develop statistics. And the problem is we are focused in exactly one kind of people who has a background and shares the same interests on certain set of statistics, on certain field. So we develop a survey, we develop a conceptual model directed to them, but we don't take into account that there are other people who can take benefit of these statistics. So we focus on developing systems for this survey. And then we put them in the national statistical offices all together in a website, sharing links to separate silos of systems and information. It looks like, okay, the presentation, how we disseminate information, looks good, looks uniform, but we don't share the same concepts. The problem is that we have a lot of interest of people trying to solve complex information needs, and to solve that, we need a way to put all these surveys, all these concepts, all this information in the same transversal platforms. And I'm saying transversal platforms because in the wild we have talked many times about integrated systems. It's crazy to think that all the people will live in the same building. That's the reason we have cities. Talking about a transversal platform is like developing all the communications, all the infrastructure that we need to have this kind of sharing of statistics. So the proposal goes to build these transversal IT platforms, because I have a IT background, but it's not just a question of IT. It's a question of statistics as a whole. With these transversal IT platforms, we try to support the whole statistics life cycle, making use of international standards and models that we have already defined, and to enable statistical interoperability. The foundations of these architectures goes in two specific ways. One is having a governance framework who will make us able to taking agreements, of making agreements inside our organization, because we need to have this common understanding of concepts, of classifications, and so on, and having an architecture to align concepts and how to structure all the things. For this, we have two tools to work about this. The Data Governance Framework for Statistical Interoperability, which has been recently released by the HLGMOs, supporting standard groups. And, well, this is the Open Group Architecture Framework for standard for enterprise architectures, the TOGAF. Oh, sorry. The governance framework provides us with 4 main elements that we need to state this environment to drive all the decisions. Organization is very important, and to help a statistical organization, we have GAMSO, which defines the main activity areas that we have in any organization who is in charge of official statistics, but any organization which develops statistics will have this kind of activities. And other model that can help us is the SDMX governance that SDMX has adopted, as they need to put 8 international organizations aligned to have agreements about an standard. And I think that this is a good model that we can follow. If 8 international organizations can have agreements, maybe internally our organizations can do that between the departments, between the areas. Then we have the processes. Which are the processes that we are going to follow? And, well, as a guide, we have the GSBPM, General Statistic Process Model, which defines the statistical life cycle, the phases, the sub-process, all the activities that are directly related with the production of statistics. It's having a definition of a life cycle that can help us to compare how the things, and also to define how we can do the things. And also we have internationally agreed methodologies which are published. Then we have the principles that will help us to speed up the way we take decisions. DAFI, the framework, I mentioned it, and also the FAIR principles are kind of these guides. And, well, we have a lot of guidelines. The Handbook on Management and Organization of National Statistic Systems, published by the UNSD, and the Modernization Maturity Model, which help us to have models to evolve in the way we are going more mature on the statistical production. Well, as I said, this is not just an IT work. It's a work where all the stakeholders, we call the stakeholder any person interested on the same objective, and the same objective is to share the statistics, need a common language. So this common language can go from the GISIM, the generic statistical information model, and, well, we have to have to structure the architecture. We are following this way because it helps us to have an enterprise-wide information model. And, well, this is the INEGI building, the main building of our statistical offices. We support the statistics, but when we adopted the GSBPM, the areas that are not directly participating in the GSBPM wanted to see how they cooperate in the production of statistics. GAMSO is the way to say, okay, you are related to human resource management. You are here. You are the supporting of the production of the statistics. Then we define it that all the information programs that we have will be following the GSBPM and define it as set on input and outputs, which can be described as JSON objects, as the deliverables of these phases of production. And to manage the data, we have as a reference the SISDA as a way to do that. Now, talking about the statistical interoperability, time is running and I'm in the half of, okay. Okay, well.
I'll cut your mic.
Yeah, I'll try to go faster, but if not, I can speak later with you if you keep interested on something that I missed to say. Okay, when we talk about statistical interoperability, we cannot talk just about putting with tools all the information like in the same bag. We need to talk about syntactic, semantic, structural, and system interoperability. If we don't share the concept, if we don't share a structure, if we don't share the syntaxes, and we don't have a way to communicate by electronic ways, we will not have interoperability. All these elements are important. And if we go in this way and we put since the basis all the information, and I think that I defend that SDMX has tools that can, in the information model, it's not about the formats, it's about the structure that we can develop, putting just in the basis, concept schemes, list of concepts, where each concept is identifiable, we can be able to have the FAIR principles. And if we want to connect all the information, we need to share three main things. The concepts, of course, with the domain about them. Geographical reference, because we are going to talk about the same places. And the time. If we do that, we can have time series in geographically referenced of any domain. I know that I'm finishing. Sorry, I don't want the ninja, please. But, okay. We have a ESBPM mapped to the management of all the data, and we have some gaps. We need to work on that. Of course, there is some gaps that we must fill. Technologies is at the end of this, but technologies have one thing that is very important. The thing is, they can enable process that used not to be possible. But in the opposite way, they cannot drive the objectives that we have when we develop statistics. So it's in both ways. But let's not be confused, because we have a lot of technologies, and we can enable a lot of things. But as an example, we are talking about ChatGPT and so on. Technologies doesn't produce magic. If we don't have the data to do that,
please
if we don't have the structure,
if we want to have time for questions, you have to.
Yeah.
Sorry.
Yeah, sorry.
Just sum up. And in this way, we'll have 3 minutes for questions.
Please.
Maybe more at the end. But you have time to conclude.
Well, I will conclude. Just this is how we are structuring this at INEGI. As an example, these are the conclusions. Don't worry about it. Okay, first of all, we need a high-level governance framework. If not, we are not going to be able to drive the efforts. Second, the transversal platforms are a concrete option to achieve fair principles. Third, we decide, we need to adopt these fair principles. I think that when I read it, I got convinced about how useful they can be to improve the information management and the implementation of better information services. And fourth, we need to know what is already in the environment before creating things that maybe we already have. So this is something that is a lesson. And okay, if you have any questions, in my 2 minutes of
1.5 now. But no, please, if you have questions, and thank you so much for a very interesting talk. Sorry for the time. And for stressing you.
Here's Barbara Magana from GoFair Foundation. And actually, I want to address your last sentence. How do you want to find out what is out there? Where do you find this? So I give you an option where you can find existing solutions, existing standards. We have Fair Connect now, which is a search engine about fair supporting resources that can help to find solutions that others have already built for you.
Well, if I understood well the question, we are on the same community. And on conference like this one, we can be aware of those efforts, of the standards. Sorry? You have to go closer to the here is better? Okay. So this kind of conference and staying closer to As an example, the statistical global platform and the channels of official statistics can help us to be aware of this work. Maybe this is not enough. Maybe we need a stronger community of academy working together with the people in charge of official statistics, not only at the national level, but at international level. And this is some speech that I have heard since a while ago. Maybe it's that this is a first step on going in that way.
Thank you so much. And thanks again for a very interesting presentation. Time's up for now, but if we have time, we'll take questions in the end. And I also invite you to speak during the break. So our next presenter is Cecilia Casagrande, who's been working at the Italian Institute of Statistics since 2002. At the beginning, she was in the national account sector, but she changed in the metadata sector 9 years ago. She's now in charge of activities related to structural metadata, and one of the activities that she's carrying on now is developing with a team of colleagues a project for managing all types of metadata that are available into their institute in a centralized way. The floor is yours.
Thank you, Alina. I'm going to talk about how in our institute, through metadata, we are trying to support all production processes and how we are actually managing the harmonization activities of those concepts included into the Italian integrated system of register. Okay. During the last decade, the Italian National Institute of Statistics has been engaged in a modernization program involved the revision of the statistical production model. This modernization of the production process has been achieved by preparing this Italian integrated system of statistical register, and it's a complex system that gets started by the integration of one or more sources, administrative register, surveys, and other statistical register. And the system is mainly built for supporting the consistency of statistical production processes, improving the quality of information of users. This is one of the main goals of the system, promote decentralization of activities, and give up a silos model of the production process that we have already that is already in our institutes. The Italian this system is composed in that way. There are 4 base statistical register and others called satellite. The satellite register are further divided between those called thematic and those called extended. The base types provide some basic information about a defined population. The extended types expand the set of information for a specific population related to the base. The thematic ones does not be constrained into a specific population, but they were built with the aim to apply on a set of core variables, shared and integrated processing methods, and at the same time it aims to support different processes that can refer to different units as a person or economic unit. The most important thematic register that we are building are labor register, education and training register, and the disability register. Right now, each of those has a different level of development. Integration between register was carried out through methods able to ensure the formalization of a set of cross concepts in terms of unit and variables used into the register themselves. So how we did manage these harmonization activities? We started by defining the main elements that typify the base unit of each register, and we can identify 3 macro steps. At the first phase, the need was to fix which were the elementary units related to the main actors for the register under study. At the second phase, we have fixed the main variables with the enumerated value domain that consent to create the population of interest for each process related to the register. At the end, we have fixed the information about the starting time of the relationship between units defined at the step 1. Those activities were carried out from a group composed by different experts that have different roles inside our institute. So thematic, methodological, and architectural experts were involved, and they are together, they put together. Okay, in this use case, I'll present the labor register and his base unit, that it is a job. As you can see, the basic piece of this register is the concept of job, and this concept in a different ways is considered by many different processes, national accounts, satellite register of employment, inside the base register of enterprises on employment, and into the labor force survey. The method followed is to define a concept in a general and in a very broad level, valid from several situations. After this general concept was adjusted according to the specific needs of the processes by taking into account all features requested by a specific laws or regulation. In order to achieve a shared base units able to be compatible with the different needs of the processes, we have compared the main sources that consider the job concept. As you can see, one of them is the regulation used in the national account concept, and the second one, the job definition inside the 19th International Conference of Labor Statisticians. The definitions are quite different between them, but they also have some elements in common. Those are in red into the slide. Beyond the name of concept, they share the main actors consider and the object of the concept.
You have 4 minutes left.
4?
Yes.
Oh,
sorry,
God.
we showed
Okay.
the 5.
And the main of the expert group was to find a minimal nucleus about the concept by focusing on what was in common between different definitions, and starting from this core concept, identify all other elements that allowed to obtain a tailored concept for each process. We have basically fixed a very broad definition, and contextually we have detailed each single element that characterizes a job concept. Through this template, it was arranged, a set of constraints are provided. The elements are the subject involved, the form of work considered, the starting time of the job, and the regularity or not of the relationship. When we match each element of the broad definition with the different domains of a set of variables, we obtain that the base unit of the register can be easily adapted in many different reference contexts. This is an example that shows how the general definition of the unit type job fit for all purposes. It is possible to select from the register a set of units for a specific process by introducing appropriate queries on the job's metadata components, person, economic unit, for all work, starting time of the job. And as key Do you read? Yeah. As can be noticed, for each process, it is possible to fix a specific constraint. For instance, related to the subject person, this can assume different connotation between the processes. In the national count, there are not particular restrictions. On the contrary, for labor force survey, just the residents are covered and with a specific age. The same thing occurs for the other object, the economic unit, that in some case involves just the resident ones, in other case both resident and non-resident. This is the case, the use case of the Register of Education and Training. The approach was the same. We have model starting a very general definition, and also in this case, by a set of variables with enumerated value domain, it is possible to reach many different, many different populations, useful for several processes. Here the process follow in order to achieve a formalization of cross-concept considers those thematic steps. The first activities that have to carry out regard to identify and pick the main concept to be formalized. Secondly, the source analysis and comparison activities was done. After it is essential the cooperation between different experts, because thanks to this cooperation can come through the project to build a really integrated system based on the role that the structural metadata can lead. At the end, a validation and dissemination is done. And from the approach, derive certain goals that can be obtained through the collaboration between experts in those formalization activities. It led several benefits that are in terms of integration of the information between processes and between different phases of the same process. In addition, it must be considered the opportunity to achieve a solid and structured organization of the concept on the basis of a metadata model. And thanks to the correct use of the variables, it can be clearly explained where and how the same element can assume different meanings in specific contexts. In this way, a unique information appropriately handled becomes actually reusable. I think I'm running out of time, so thank you for your attention.
Thank you. But if you want to say a phrase to conclude, please go ahead. You have 20 seconds.
Okay. Okay.
Because you stopped talking.
I'm scared of the time.
Yeah, I see, but don't be.
Now, something about the critical issues that remains in this case, because our experience has shown that the harmonization process produces a high level of time consuming for reaching good results, and it's directly linked with the burden that derives for all experts involved in this harmonization activity process. This effort can produce dubs on the real benefits that can be gathered by the process involved in those formalization activity, and I think that it's very important have a big effort in passing the metadata culture, because it's a very strong goal for our institutes. Very often the production talks with us, and they ask to us, but it's really important, all of metadata, they feel a very burden of these activities, and it's a pity, because we think on the other hand that they are very important for understand really the data and for offer several services to the community, internal and external, of the statistical institution. So thank you again.
So questions?
More an observation than a question. It struck me how similar this presentation was to what was presented about iAdopt yesterday. Is that this idea that you're describing the definitions of the concepts and constraints in relation to units and the context. I think that's a very powerful idea. I like this method of getting to that state of clarity. But it does remind me of the work in iAdopt as a standard.
Thank you. We still have time for questions. While you think about it, I had a question on your harmonization process. Could you develop on that? How you did it? Maybe I missed it, but was it? Did you do it manually or automatically? And what was the? Yeah.
It's very manual at the moment. Yeah, we are building a system that, and we hope to can can be really automating this process. But at the moment, it's very manual. Yeah. And
how many people are involved? How do you conclude?
In the metadata team, we are 5. We are different people. One of them is Claudia Brunini, and there are some with the structural metadata, some referential. So 6-7 person with a different role, but the hard job is to involve the production expert, because they are central for the harmonization, and it's not often easy. Yeah.
Thank you so much. We still have time for one question. Okay, maybe at the end, we'll try to have some minutes for questions in the end. Our fourth speaker is Halima Bakia, who works at the French Secure Data Access Center, CASD, as a data manager. She guides researchers in their application procedures to access French data and controls the statistical confidentiality of the results they wish to publish. She documents data made available by the CASD in the DDI format, using information supplied by data depositors, and makes it available on the CASD website. She will have a short talk paper today to present. Please.
Thank you, Alina. So, hi everyone. As Alina said, I work at the CASD, and I will present to you the experimentation we have done with my colleague Ifaliana Rakoto-Arezoa and Thomas Dubois from Insee about the exchange of documentation. So to begin and provide some context, I will briefly introduce our two structure. We will then review the current situation and the current process of data and metadata dissemination. Next, we will delve into the experimentation, exploring the experimented workflow and the expected benefits. So to organization, a data producer Insee on a part, and the data disseminator CASD in another part. Insee is a French national statistical institute, and Hermes is the statistical metadata repository. The main purpose of Hermes is to centralize statistical metadata in a single location, standardize their description, facilitate their reuse, both by man and machine, internally and externally. So to make some confidential data and metadata securely available to a researcher, Insee relies on the French Secure Data Access Center, the CASD. Its main mission is to organize and set up services of highly secure access to confidential data for users pursuing non-profit research, study, or evaluation purpose. So how does it work? An accredited users access the data through a dedicated hardware file client called the SD box. This box is linked by a secure tunnel to the user's project work environment called a secure bubble. Each bubble is isolated from all the others, and the users cannot insert or export data from his environment without a checking by CSD teams. For some key figures, from its creation, more than 5,000 users have worked on the CSD in more than 1,500 research projects. Data available at the CSD are diverse. They are administrative as well as survey data. A wide range topic of is covered, company, as well as health, justice, migration, or agriculture. Currently, the CSD provides access to more than 500 data sources that are mainly produced by Insee and statistical department in ministry, but also from different public institutions. For the documentation, we use the DDI standard. So Collectica software is used to manage DDI metadata. A presentation of the sources, a summary with essential information. A list of variables and modalities are made available to the researcher on the CSD website. The main purpose is to help the researcher identify relevant data for their project. Users who wish to access data need to know their content and to know whether they correspond to their research subject before submitting the application for their project. The procedure for accessing data could be very long and quite difficult, so users should know what they will have access to in order to avoid undertaking unnecessary steps. Moreover, no data providers whose data is made available by the CSD offer this information online in such detail. In the previous works, Insee and the CSD very early engaged into a partnership on documentation, in particular with the agreement for the implementation of Hermes, which uses DDI, and it leads to CSD information system into line with the reference metadata disseminated by Insee. So for the current process, we have on the step 1, Insee transfer data to a CSD. We download the documentation, which is not standardized. Documentation is built upon several documents from Insee delivering application. So file structure, codebook, methodological documentation, questionnaire, source code, and many others. All the work for transforming the documentation in DDI is done by CSD using the Collectica designer software in a dedicated secure environment. For the step 3, after this DDI metadata is extracted in XML format, and for step 4, it is then uploaded from the secure environment in an internal application, a tool developed by the CSD for supporting DDI standard for displaying on the CSD website. And for step 5, CSD asks Insee if any information is missing, and after the feedback, CSD modifies the documentation if necessary. For the experimentation, what we have done, it's matching the documentation's architecture of Insee and CSD with DDI standards enabled the exchange of XML files. So, for the experimentation, metadata already documented in DDI in both organizations has been chosen. The data file produced by Insee has been chosen, also known as BTS. Insee sends the DDI documentation, we import it in Collectica, and we export the XML like in step 3 of the current process. The aim is to achieve the same result online if the DDI documentation is supplied by Insee or it's produced by CSD from non-standardized files. If necessary, information has been harmonized, attribute to the correct name and description of a data file. The result has been compared with the already published metadata for the same file. Even though the experiment revealed the need for harmonization of practices, it worked quite well. So the purpose in mind is to be able to exchange DDI and XML metadata at a higher level, in particular at the level of a study. This eliminating steps 2 and 3 and moving on to the target workflow, which is much lighter because the heaviest task disappears. So here's the list of some of expected gain. On the most important is on the workload. And to summarize, we have the main purpose of the CSD online documentation to provide users with an overview of the confidential data available in the secure area. Due to the large number of data sources available, more than 500, data documentation for us is time-consuming. So the experimentation shows some of the benefits of sharing the same standard. It's very promising, and it facilitates reusability and speed up documentation display. Harmonization of documentation process will reduce the reinterpretation of meaning of variables. It also allows a better understanding of the metadata sharing landscape and practical insight into future needs. It requires to define and share precise best practices in order to avoid remanipulating DDI file and so fluidizing the workflow. I'm going to more detail on the paper, which is based, this presentation is available, but for now, thank you for your attention.
Thank you. Any questions? You have so we have a question right here, so it's okay. Okay. Right.
No, my question was what are the next steps? Because you still have 2 minutes to go through the next steps.
Yes, it's a big experiment, but the next step is the target process we have shown. So we want to put it in place and not just experiment it. So we still need to discuss between the CSD and Insee the implementation process with us, with you and us.
We have a question from Archana who wanted to, if it's okay.
My question is, how did you agree on the profile between the two organizations and the challenges there, and how long did it take?
We start, I don't remember when we start, maybe. We discussed just in like that in a conference, and we said we must try. And after that, we start in next summer, I think. And it's made a quite good improvement, so we need to continue.
I think diplomacy is the key here.
Please.
Yeah, Matthias Hughes, Statistics, Netherlands. So, thank you. Very interesting presentation. We have a kind of similar facility at Statistics Netherlands for scientific research. Mm-hmm. And one thing that we have, and it's a bit challenging from the metadata perspective, but maybe also other perspective, is there is, desire by many researchers to bring their own data and link it to statistical data and then research it. And we have this service, mm-hmm. but that means that, collaboration between two organizations on metadata becomes, collaboration between many other stakeholders. So do you have this approach or see the need for it or no?
Not yet. So for the moment, we just made the experiment, and the users don't send us, like you said, the document. We took the document from Insee when we have the data, and we do the documentation, like I said, in step 2. It takes, for example, for the DADS post who have 175 variables, it can take 2 days, and in the experiment we have just 2 hours. So it's a many improvement.
Hi, thank you for a very interesting presentation. I'm here. Sorry. Outside from Insee data, you have data from like 1,000 institutions on the CSD. So how do you take this data in? Like, do you have a quality control process? Do you trust institutions to give you clean and proper data?
For the data?
Yeah.
We have a process between CISD and the producer. All the new year, like for the ADS, the producer send us the new year, and we have the Insee have a data archive who made available the documentation, and CISD have how do you say it?
CISD French, I'll translate.
I don't know. Yeah, share with Insee the documentation. So we have a privileged workflow with Insee.
Other questions, comments?
I have a comment. Okay. I think this is very incredible and interesting because this is something we've been trying to achieve with our other partners, major stakeholders who send major data with us. We want to develop this kind of relation where we have predefined metadata profiles and references, so the quality of metadata coming into our systems are already at a higher level, and a lot of manual work will go down. So this is very interesting. Thank you so much.
Thank you. We still have 4 minutes, so if you have questions for the other presenters, yeah, please go. I didn't see you.
No, it was just to complement the answer on the first question, because the first phase of harmonizing the vocabulary just between CISD and Insee, it took us, I would say, something like 1.5 years. So it's really, really, the main work is there. Mm-hmm. After that, agreeing on formats and everything is made much easier, I would say. So, but it was basically 4 people, but 4 people knowing very well their job.
Thank you. Other questions for the other presenters? Maybe no regrets, no.
Lucy from the CDSP. I'm just wondering, because some of the presenters choose to not use the concept, and some of others really focus on the concept in the process of metadata linkage and harmonization. Maybe from Sikt, you said you stopped using else thesaurus. Can you tell a bit more? Yeah, develop on this point, please.
The decision, we wanted to adopt thesaurus else, but it's too subjective when tagging the keywords come to. And we wanted to reduce subjectivity in the metadata we add. And that is why we went away from the keywords. And the reason we went away and how we improved, the other hand, is our variable level metadata. All variable level metadata is now indexed. So people can search at question text and everything and get. So we think the search has improved so much that you don't need keywords, but you can just search and get what you want. You can actually get the exact variable you're looking for, if you know the question.
Yes.
About this keyword thing, to index this variable information, did you enrich the information about these variables somehow?
Oh, we did. The major change from static to metadata was hyper enrichment we did. So we did a lot of control vocabularies mapping, and we have added a lot of data like what is the weight, what is the type, which variables are geographical, and which are population, age. All that kind of description is part of the metadata and is persistent, version controlled, and machine actionable. So all that, we did part of it as part of the bulk migration we did. We had Collectica develop custom migration services for us, which did part of the work, and later on we did manual checks. So that has helped us.
Thank you. One last question, yeah.
So I certainly agree with Archana that the keywords are not necessary, but there's another question about how do you identify which variables are the same. And so, I worked on this at ICPSR at a time where we had 7 million variables in our variable search. I think it's now over 10 million. And once you get then the kind of search that you're describing, you wind up with too many results. And that's why I'm really excited about the kind of thing that Cecilia is doing, and also what Barbara's doing with iAdopt, because I think that can produce a path where we can identify things that are related and be able to search in a kind of a hierarchical way, so that we could finally find out how many variables we have. Because in that 10 million variables at ICPSR, we have no idea how many unique variables there are.
Thank you so much. Do you want to...
I can just add, we use the CESTA concepts at a higher level. But for the Norwegian archive, the data sets are not harmonized across the studies. But for ESS, they are. So we use cascaded variable cascading there. But for the research data archive, they come from different sources, and we don't take cross-study harmonization effort.
Thank you. So please join me in thanking our presenters for a really interesting session. And thank you for all the questions. It was interactive and really nice. Thank you.
And thank you, Alina, for